Hello friends, welcome to SSP Math. Today we are going to take some problems on Legendre differential equation. So problem is solve 2x plus 1 bracket square into d square y by dx square minus 2 times 2x plus 1 into dy by dx minus 12y is equal to 12x. So how we write solution of this Legendre differential equation? For solution first we have to convert this Legendre differential equation to linear differential equation with constant coefficient, and for that we have to use some substitution. That substitution is 2x plus 1 is equal to e raised to z here, or z is equal to log of 2x plus 1. And again one more substitution is there, that is 2x plus 1 into dy by dx is equal to a dy. What is the value of a here? A is 2 into capital dy. Capital D is d by dz. Second one is 2x plus 1 bracket square into d2y by dx square is equal to a square. A square means 2 square. 2 square is 4d into d minus 1y. Now using this substitution, given differential equation can be written as 4d into d minus 1y minus this 2 as it is, and the value of 2x plus 1 dy by dx is 2 dy, so into 2 dy minus 12y is equal to 12x. 12x is, we want x in terms of z. So if you put here 2x plus 1 is equal to e raised to z, then try to find x using this. So how we write 2x is equal to e raised to z minus 1, and then x is equal to e raised to z minus 1 upon 2. So the value of x is e raised to z minus 1 upon 2. Now from LHS if we take y common and multiply this 4d inside this bracket, so 4d into d is 4d square minus 4d, this minus 2 into 2 is 4d minus 12 into y is equal to, this 12 by 2 is 6 into e raised to z minus 1. So this is phi of d into y is equal to f of z form A, that is linear differential equation with constant coefficient. Now what is this complete solution? Its solution is y is equal to cf plus pi. So for this we have to find first complementary function and then particular integral. So for complementary function we want roots of auxiliary equation. So auxiliary equation is here 4d square minus 4d that is minus 8d minus 12 is equal to 0. Now how we find roots here? I think if we divide throughout by 4, then this becomes d square minus 2d minus 3 equal to 0. So d square minus 2d minus 3 is equal to 0. So what are the roots of this? If we take b square minus 4ac here, 4 minus plus. So what are the two numbers whose sum is minus 2 and product is minus 3? Yes. What are the two numbers whose sum is minus 2 and product is minus 3? 3 and 1. Minus 3 and plus 1. Means we can write d minus 3 and d plus 1. So minus 3 plus 1 is minus 2 and minus 3 into 1 is minus 3. So this is equal to 0. So using this we can write d is equal to minus 1 and d equal to 3. So these are the roots of auxiliary equation, and therefore complementary function is equal to c1 e raised to minus z, because Legendre's differential equation है, capital D is again d by dz plus c2 e raised to 3z. Now what is the value of z? E to the power z is equal to 2x plus 1, then what is e to the power minus z? That is 2x plus 1 bracket raised to 2x plus 1 bracket raised to minus 1 plus c2 into 2x plus 1 bracket cube. So this is the complementary function. Now for complete solution again we want particular integral. So how we find particular integral? We know formula. Particular integral is equal to 1 upon phi of d 1 upon phi of d, and phi of d is here 4d square minus 8d minus 12 into f of z. Here f of z is 6 into e to the power z minus 1. So for pi we have to split this in two parts because two terms are there, e raised to z and 1. So can be written as 1 upon 4d square minus 8d minus 12 into 6 e raised to z minus 1 upon 4d square minus 8d minus 12 into 1. Not 1, 6 into 1, that is 6. Okay, so after simplification, this is, in first we have to use your shortcut method because exponential function present only, and if exponential function is present then we have to put d equal to a. So what is the value of a? A is 1 here. So if you put d equal to 1, 1 square is 1, that is 4 minus 8 minus 12 into 6 e raised to z minus, here constant term is 6. And if constant term is there, then we have to put d equal to 0. Constant term is e to the power 0 z because e raised to 0 is 1. So if you put d equal to 0 here, so 1 upon 4 into 0 minus 8 into 0 minus 12 into 6. So after simplification, this is minus 8 minus 12 is minus 20. Minus 20 plus 4 is minus 16. So minus 6 upon 16 into e raised to z. This is this minus is plus 6 upon 12 is equal to minus 3 by 8 into e raised to z. What is the value of e raised to z? 2x plus 1 plus 1 by 2. So this is the particular integral, and therefore final answer is y is equal to CF plus PI. So you write this CF here and then write PI. That is the complete solution of given differential equation. So next problem is solve x plus 1 bracket square into d2y by dx square plus x plus 1 dy by dx plus y is equal to 2 sine of log of x plus 1. So this is again Legendre's differential equation. So we have to convert this Legendre differential equation to linear differential equation with constant coefficients. So for that we have to use substitution here. X plus 1 is equal to e to the power z, or z is equal to log of x plus 1. Okay, and next substitution is same as last problem, that is x plus 1 into dy by dx is equal to a dy. But what is a here? X plus 1, if we compare with ax plus b, then a is 1, so 1 into dy, and capital D is d by dz. Then x plus 1 bracket square into d2y by dx square is d into d minus 1 y. So this is the substitution. Now using this substitution we can write given differential equation, that is d into d minus 1 y plus x plus 1 into dy by dx is dy plus y is equal to 2 into sine of log of x plus 1. So what is the value of log of x plus 1? That is z. So is equal to 2 sine z. So from LHS if we take y common, then this becomes d into d minus 1 is d square minus d plus this d plus 1 into y is equal to 2 sine z. Okay, so this is again phi of d into y is equal to f of z. And if phi of d into y is equal to f of z means that is linear differential equation with constant coefficient. And what is this solution then? Solution is y is equal to CF plus PI. So we have to find complementary function and then particular integral. So for complementary function we want auxiliary equation. Now what is auxiliary equation here? D square, this d get cancelled. So this problem is very simple. Auxiliary equation is d square plus 1 equal to 0. And if auxiliary equation is d square plus 1 equal to 0, then what are the roots of this? We know that a square plus b square, or d square is equal to, we can write minus 1. Minus 1 is I square. So if we take square root of both sides, then this is plus minus I. So roots are plus or minus I means imaginary and non-repeated. If we compare this with alpha plus minus I beta, then alpha is 0 and beta is 1. So complementary function is equal to e raised to 0, that is 1, into c1 cos z plus c2 sin z. Why we write here z again? Because Legendre's differential equation A and capital D is here d by dz. Now what is the value of z? Z is equal to log of x plus 1. So put here c1 cos of log of x plus 1 plus c2 sin of log of x plus 1. So this is the complementary function. Now we have to find particular integral here. So for particular integral we know formula 1 upon phi of d. Phi of d is d square plus 1, and right hand side, that is f of z of given differential equation, means this, that is 2 sin z. So we can take this 2 outside, but sin z present a, and if sin z is there, then we have to replace d square by minus a square. So if we put here d square by minus 1 square, minus 1 plus 1 0, so case is fail here, and if case fail, then we have to multiply by x. Here we have to multiply by x or z, because capital D is d by dz, means independent variable x convert y z mein. So instead of multiplying x, multiply here by z and take derivative of denominator, that is derivative of d square plus 1 is 2d into 2 sin z, right as it is. So these two get cancelled, and we know that 1 upon d into f of x is integration of f of x. So this is z into integration of sin z dz. And what is the integration of sin z? Integration of sin z is minus cos z. So this is equal to z into minus cos z. Now what is the value of z? Z is log of x plus 1, this minus sign right here, into cos of log of x plus 1. So this is the particular integral. Then how we write final solution? Final solution is y is equal to cf plus pi. Y equal to cf plus pi. So you write this here, cf is this and pi is this. Take addition of these two, then we will get complete solution of given differential equation. Thank you.